For today's class, we are going to look into a kind of geometry called coordinate geometry. So when you hear the word ordinate, ordinate means a point on a particular axis, either y or x axis. So coordinate means, a point that represents a pair of points. Consider this Cartesian plane. So this is the vertical axis, let's call it y axis. While this is the horizontal axis, let's call it the x axis. Where these two axes meet is called the origin, labeled 0. Suppose we have a point on this x axis, this point, let's call it x1. And we have a point on this y axis, let's call it y1. So these are what we call ordinates. So there's a point on this plane that represents x1, y1. Let's show the point. Show this one up and this one to the right. So they met here. So let's call this point, let's label it A. So it means the coordinate of A is x1, y1. Let's pick another point on the x axis. Let's call it x2. Same for y, let's call it y2. Let us join it together and call it point B. So from here, it means the coordinate of point B is x2, y2. Now, if you have 2 points in space, like point A and point B, we might be interested to know the distance between them. To know how far B is from A, let us join the 2 points. And let's call the distance between them, let's call it small d, little d. If we move from point A to point B, then vertically we've moved from y1 to y2, and horizontally we've moved from what? x1 to x2. Let's show that. So during that movement, there's a little change in x. Same way from A to B, we move vertically from this point to this point. That's a little change in y. This vertical line, this horizontal line, definitely is what? 90 degrees. And what happens here? This is a right angle triangle, then we can apply Pythagoras theorem. So we can get distance by applying Pythagoras theorem. This d is the hypotenuse. So we can say the square of d equals to the square of x, change in x, plus the square of change in y. To get d, we find the square root of both sides. From that place, we get d to be the square root of change in x square plus change in y square. So the question is, what is change in y? Y change from y1 to y2. So the change is what? y2 minus y1. Same goes for x, x2 minus x1. Then we can replace it here, and at the end we have this formula. So with this formula, we can look for the distance between 2 points if their coordinate is known. Then the next thing, we might be interested to know the midpoint of this line. Midpoint is a line that divides AB into 2 equal parts. So let me call this one, you are done with this D, let me call this M. What's the coordinate of this midpoint? So the coordinate of the midpoint M, let's call it xm, ym. What is xm? This point, we can trace it to the x as this xm. Then we can trace it also here. So this is ym. So our aim is to get the value of xm and ym. From here, it is obvious that distance between x1 and x1 and xm is the same. So from here we can say x2 minus xm minus x1 should be the same thing. Same goes for y. y2 minus ym minus y1 should be the same. And from here we can make xm the subject and ym the subject. And this is what we're going to get at the end of the day. So we can write the coordinate of the midpoint as. So this means that we can always get the coordinate of midpoint of a line if we know the coordinates of the extreme point of the line. Another thing that is very important for us to know about a line is what we call the gradient of a line. Before we go to the formula to calculate the gradient m, which is also called the slope of a line, let's try to understand it. Consider this Cartesian plane and let's draw 2 lines here. If we compare line 1 to line 2, so this particular line 1 has higher slope or has higher gradient than line 2. If I'm to place a particular object here and place another object here, this object here will roll down faster than this object. So this one is steeper or we say it has higher slope. So slope is usually a measure of the angle the line makes with the horizontal. So for this line 1, this is the angle it makes, which is bigger. This makes a smaller angle. So if the angle is small, the gradient is small. If the angle is large, the gradient is large. So for this line 2, this is the change in y-axis. From here to here is the change in x-axis. Let's extend this one to a point whereby they will have the same what? Change in what? Sorry. They have the same change in x-axis. We can say this particular line, this is change in x. This line, this is change in x. What happened for line 1? The change in y is longer. It is from here down here. For line 2, it is just this one. So in this case, for line 1, the gradient, let me call it m1, equals to the change in the y-axis to what? Change in what? X-axis. So that is what in general. Change in vertical axis over change in what? Horizontal axis. So we can come back here and write the formula of gradient there. Now, let's generalize. Suppose the angle this line makes to this horizontal is alpha. So we can say this is opposite, this is what? Adjacent. So from there we can say tan alpha is the ratio of the opposite to the adjacent. The change in y over change in x is still what? The gradient. So from there we can say the gradient of a line is what? Tan of the angle the line makes with the x-axis. So this is formula to calculate the gradient of a line. Or from here we can also say the gradient of a line equals to change in y. What is change in y from here? Change in y is y2 minus y1. So that is y2 minus y1 over what is change in x? x2 minus x1. So these two formulas are important to calculate gradient of a line. This one in terms of the angle the line makes with the horizontal. This one in terms of what? The coordinate of 2 points on that line. Any 2 points on that line. So if you pick any 2 points on this line. So this is what? x1, y1, x2, y2. Then we impute that to get the gradient. Another thing that interests us under coordinate geometry for a line particularly is what called the equation of a line. Equation of a line. We'll talk about gradients, coordinate of midpoint, distance between two lines. Now to calculate the equation of a line, we have two general forms. The general equation of a line is represented as this. Y equals to mx plus c. We use this particular equation if we know the intercept. What is intercept? I will explain now. But if we don't know the intercept, we simply use this as the equation of a line. The gradient equals to y minus y1 over x minus x1. Okay, let me now explain how these two equations come to be or come about. Let me explain. Back to our Cartesian plane. Suppose we have a line. So this is the origin 0 as usual. And this point, the point where this graph or this line cuts the y-axis is called the intercept C. So C means intercept, where the line crosses the y-axis. So in general, intercept is taken to be a point where it cuts the y-axis. But whenever it's called the x-axis, it's also an intercept, or in that case we call it what? Intercept on x-axis. Let's consider an arbitrary point on this line. So this one, let's call it x. Let's call it y. We don't want to put the value there. From here, this line, let's choose a point move from here to here. So if this point moves from here to here, it means along the x-axis, the change in x is x minus 0, which is x. And vertically it will move from here to here. And the change is what? Y minus c. So this is y minus c. So the gradient of this line m is what? Change in y-axis to change in x-axis. So the gradient here becomes, what is change in y-axis? Y minus c. Change in x-axis over x. By the time we cross multiply, we are going to have y minus c equals to mx. Then y equals to mx plus c. That's how this first one is gotten. Now, suppose we don't know the intercept. What are you going to do? You can write this down, please. If we don't know the intercept, let's pick a point on the line whose coordinate is known. If the intercept is not known, the coordinate of the point must be known. So let's pick a point here. And for this particular point, the coordinate will be x1, y1. So if we are choosing this point, from this point to this point, so the change in x will be what? X minus x1. This is y minus y1. This is x minus x1. So the gradient m becomes what? Y minus y1 over x minus x1. Y minus y1 over x minus x1. So to get the equation of a line, two things must be known: the gradient and the intercept, or the gradient and the coordinate of the point in that line. Now the problem now is that sometimes we are not going to be given the gradient at all. So, but we are going to be given other hints on how to get the gradient, and that's the next thing we are going to look into. Before moving to the next area, which is angle between two lines. From here, the equation of a line can be gotten, like I said, if you are given the gradient and coordinate of a point. Sometimes you won't be given this m. So if m is not given, and we have coordinate of 2 points, so this is formula to calculate what? Gradient given the coordinate of 2 points. Or if you are given the angle a line made with the horizontal, you can use this one. So either this formula, so we can equate this y minus y1 over x minus x1 to this, or to this. Or sometimes we are going to be given a particular information about a particular line, and be told to get the equation of another line inclined to it. Check this graph. Okay, suppose we have this line. Okay, let's suppose we have another line inclined to it. Okay, let the arc angle between them be this. So this is the angle between the two lines, theta. So this first line made an angle alpha to the horizontal, this one also. Let's call this alpha 1, this alpha 2. This shape is a triangle. For a triangle, the exterior angle of a triangle, which is alpha 2, equals to the sum of the opposite interior, alpha 1 plus theta. So the main on the subject means theta equals to alpha 2 minus alpha 1. Then let's take tan of both sides. So tan theta equals to tan alpha 2 minus what? Alpha 1. And recall the compound angle for expansion of tan. If we have tan A minus B, so the answer is tan A minus tan B divided by 1 plus tan A tan B. So in this case, you can say tan theta equals to, we replace A with alpha 2, B with alpha 1. That will be tan alpha 2 minus tan alpha 1 divided by 1 plus tan alpha 2 tan alpha 1. Suppose the gradient of this first line is m1 and the second line is m2. Recall from here, gradient is what? The tan of the angle made the horizontal. So obviously it means the gradient of this first line is what? Tan. What angle does it make? Alpha 1. And for this second line it is tan alpha 2. So we can come back here and write that tan theta equals to tan alpha 2 is m2. Tan alpha 1 is m1 over 1 plus tan alpha 2 is m2, then multiply by m1. And with this formula, we can always get the gradient of line m2 if you know line m1, the gradient of line m1, and the angle between the two lines. So suppose the two lines are parallel, parallelism. So when two lines are parallel, the angle between them, theta, is 0 degree. Meaning if this is the first line, this is the second line, they will never meet. So the angle between them is 0. So when they are parallel, let's suppose this one is m1, this one is m2. What will be the gradient of m2 if you know m1? So we'll come in and replace this theta with 0. So tan 0 will be the what? The value of theta. What is tan 0? Tan 0 is 0. Or we can write as 0 over 1. So for value of tan 0, it is 0. And for a fraction to be 0, it means the numerator is 0. So in this case, it means m2 minus m1 is 0. We compare the numerator together. So, and from here, we can say, if you bring this m1 here, so it implies that m2 equals to m1. In short, when two lines are parallel, the gradient of the first line equals to the gradient of the second line. Secondly is, what if they are perpendicular? That is perpendicularity. Suppose this is a line with gradient m1, and we have another line with gradient m2, and they are perpendicular. If they are perpendicular, it means the angle between them, theta, is 90. So what is theta 90? tan 90 is undefined, which can be written as 1 over 0. So it means for tan 90, if you have any fraction that is equal to tan 90, the denominator is 0. And what do we have here as denominator? 1 plus m2 m1 must be equal to 0. From here it means 1, or you can say m2 m1 equals to minus 1. So to get value of m2, we can divide by m1. So m2 becomes minus 1 over m1. So if two lines are perpendicular to each other, the gradient of the second line is negative what? Reciprocal of the gradient of the first line. So if you are told that a particular line is perpendicular to the other, if you know the gradient of the first line, you can get the gradient of the second line. So in short, if you know the angle between the two lines, we can know the connection between their what? Gradient. And if we know gradient of two lines, if you know m1 and m2, we can always get the angle between the two lines. Note, theta is the angle between them. Alpha 1, alpha 2 are the angles each line make with the horizontal, and tan of these angles equals to their gradient. So I think with this, we've come to the end of what? The first part of this topic, or let me call it the introductory part of what? Coordinate geometry. Now, note all this down. I want to give a question. From that question, we are going to apply almost all the formulas here. Let's see that particular question before we move or we dive further into this topic. Now look at this question. A single question, but it covers almost everything under this topic. Yes. From A to G should be easy. But Hij is not actually difficult, but I will solve it. Then after that, from the solution, we are going to generalize some things. So from the first question, the coordinates of the two extreme points of a line are minus 2, 3 and 1, 2. To solve this question, we don't need to sketch any diagram, but for reference sake, let's suppose this is the Cartesian plane, and let's say this is the line. So it means we are given the coordinates of the extreme point of the line, this point and this point. So if you trace it here, this is x1, this is y1, this is x2, and this is y2. So if these are the points, so it means, so let's call this point A and let's call this point B. So we can say the coordinate of point A, which is x1, y1, is given to be minus 2, 3. And also point B, coordinate x2, y2, is given to be 1, then minus 2. So find A, what's the A part? The length of the line. If you are told to look for the length of this line, it's as though we are told to look for the distance between A and B. That's distance between 2 points. So the length of the line equals the distance between two fixed points A and B, the extreme point of the line. So what's the formula for that? Formula for distance, D, equals to, which is the length in this case, square root of what? x2 minus x1 all squared, y2 minus y1 all squared. So let's plot in the values. So from here, it means the length equals to the square root of, what is x2? So this x2 is 1 minus, what is x1? x1 is minus 2. So that's what? Minus 2 all squared plus, what is y2? y2 is minus 2. Then minus, what is y1? y1 is 3. Then all squared. So from here, we can proceed. The length L becomes square root of, minus times minus is plus, 1 plus 2 is 3. 3 squared is 9, plus minus 2 minus 3 is 5, minus 5. Minus 5 squared is 25. So from here, it implies that the length is the square root of 34. So the length is root 34 units. As simple as that. B, the coordinates of the midpoint of the line. So what's the midpoint of the line? Let's say this is the midpoint of the line. What's not the coordinates? What is xm What is what? Ym. So if you recall, the formula is given as, so now let's put the values. What is x2? x2 is 1 plus x1 is plus 2, that's minus 2 over 2. What is y2? y2 is minus 2, y1 is 3 over 2. So let's write it linearly to save space. So 1 minus 2 is minus 1, so that's minus 1 over 2. Then minus 2 plus 3 is 1, that is what? 1 over 2. So that's the coordinate of the midpoint. So before writing, I want to clean this now, but write this step before this. I'm just doing that to save space. I want to try to solve everything here without clearing the question. Okay, the C part. The gradient of the line. What is gradient? Change in y, change in x. And from here, m equals to, what is y2? y2 is minus 2, y1 is 3. Then x2 is 1, then x1 is minus 2. So this becomes minus 5 divided by minus 1. So the gradient of the line is what? Is 5. D, the equation of the line. How can we get the equation of the line? We have to y equals to mx plus c, but we don't know the intercept. So I have to use the second one. M equals to y minus y1 over x minus x1. So we know y1 should be 3 and x1 to be what? But what about m? We've already gotten m to be 5. Then we are making value of m. We can equate this to this. Since we have m already, we can just say this becomes m is 5 equals to y minus, what is y1? y1 is 3. Then x minus, what is x1? x1 is minus 2. So from here it means 5 equals to y minus 3 over x plus 2. So that's the equation, but let's make y the subject. So from here, if you cross multiply, so it implies that y minus 3 equals to 5 times x, 5x, 5 times 2, 10. If we bring this minus 3 to the other side, it becomes plus 3. So y equals to 5x plus 10 plus 3 is 13. So this is the equation of the line. 5x plus 13. So E, the y-intercept, that is C. So we are looking for C. Recall the formula y equals to mx plus c. And already we have the equation of the line y equals to 5x plus c plus 13 in this case. So from here it's obvious that the gradient is 5 and the intercept C is 13. As simple as that. What is that F? We are looking for the equation of a line, that meaning another line, parallel to it. So meaning we have another line that is parallel to this line. And it passes through it point what? 3 minus 3. So meaning on x-axis it passes through plus 3. Then on y-axis minus 3. Guys, I don't need to draw a diagram. First, I told you to look for equation of a line, always use what? M equals to y minus y1 over x minus x1. So we are told that it passes through 0.33. So it means x1 comma y1 equals to what? 3 comma what? Minus 3. So what's the, if the gradient of the initial line, this first line AB, what was it? M1. M1 is 5. What is now the gradient of the second line? M2. Now since we are told that they are parallel, we use parallelism. When two lines are parallel, they will have equal gradients. So it means the gradient of the second line equals to what? Gradient of the first line, which is 5. So I'll come and write 5 equals to y minus, what is y1? Minus 3. Over x minus, what is x1? 3. So from here we're having, it implies that 5 equals to y plus 3 over x minus 3. By the time we cross multiply, you'll be having y plus 3 equals to 5x minus 15. 5x minus 15. So when we make this plus 3 here becomes minus 3. So minus 15 minus 3 is minus 18. So it means y equals to 5x minus what? 18. So this is the equation of that line parallel to this particular line. As you can see, they have the same gradient 5, but they have different intercepts. It means that particular line, the second line, will cross y-axis at point what? Minus y equals to minus 18. So what about G? G says the equation of a line perpendicular to it passing through this. So if the second line is M2, since they are perpendicular, we use perpendicularity. The gradient of the first line, of the second line equals to minus 1 over the gradient of the first line. It is there. So in this case, it means our M2 becomes minus 1 over, what is M1 in this case? M1 is 5 over 5. So then we use this equation again, this same formula, to get the equation like this one. So we call that the gradient of the line M equals to what? Y minus y1 over x minus x1. And here, we are told that it passed through point what? That equation G, 2, 4. So it means x1, y1, the point we have 2, negative 4. Then let's impute. What is our M? We are using this M2, which is minus 1 over 5. So minus 1 over 5 equals to y minus, what is y1? Minus 4. Divided by x minus, what is x1? 2. So this becomes minus 1 over 5 equals to y plus 4 x minus 2. So if we cross multiply here, we are having 5 times y, 5y plus 5 times 4, 20 equals to minus x plus 2. So if we divide through by y, we'll be having our y to be equals to minus 1 over 5x. So 2 minus 20 is minus 18. That will be what? Minus 18 over 5. If you make y the subject, from here, if you make y the subject, this is what I'm going to get. So that's the equation of the line. So we've done A, B, C, D, E, F, G. So H, the equation of a line inclined at angle 60 degree. So unlike F and G, for F parallel to line AB, for G perpendicular to line what? AB. So this is the line for question G. This is the line parallel for question is it F. Now for this H, the line is neither parallel nor perpendicular, but we are given the angle. So we can go and use that formula to get the new gradient. They will proceed again. Okay, for H, recall, if we know the angle between two lines as theta, or the formula M2 minus M1 over what? 1 plus M2 M1. This particular line, we've gotten the gradient with 5, that's M1 is 5. And now we are told that the angle is 60. So what I'm going to do here, we'll come and write tan 60 equals to our aim to get M2. What's our M1? 5. Divided by 1 plus M2 times 5. So from here this becomes tan 60 is root 3 equals to M2 minus 5 divided by 1 plus 5 M2. If we cross multiply, we are having M2 minus what? 5 equals to root 3 plus 5 times root 3, 5 root 3 M2. So our aims to get, so what I'll do is let's bring this one here, this one here. So we are having M2 minus 5 root 3 M2 equals to root 3. Bring this one, it becomes plus 5. Now M2 is common. By the time we factorize M2 from here, we will let it what? 1 minus 5 root 3. Because what you have there, you can write as 5 plus root 3. Anyhow, so to get M2, we divide also by 1 minus 5 root 3. 1 minus 5 root 3. So So from here, m2 becomes 5 plus root 3 divided by what? 1 minus 5 root 3. Let's try to write our answer in decimal. So to one decimal place is going to be 0.9 units, the gradient of that line. So to get the equation of the line, same way, use m equals to y minus y1 over x minus x1. So what's our m now? 0.9. So 0.9, should we write it in fraction? Let's leave it as 0.9 because it's appropriate value. Y minus, what is y1? That's 2. Over x minus, what is x1? x1, 1. So from here it implies that we are having y2 equal, y minus 2 equals to 0.9x minus what? 0.9. So we add 2 to that. So our y becomes 0.9x minus 0.9 plus 2. That will be 2 minus 0.9 and that will be 1.1. So that's the equation of the line approximately. So because using this short form will make our answer much more complex. The next question, which is a subtopic on its own, the perpendicular distance of a point from a line. We've done, let's suppose we have 2 points. We've done distance between 2 points. But now let's suppose this is a line now, and this is a point. Now I want to know how far this point is from this line. And in that case, we usually, focus on the perpendicular distance. So this is the original line, which is this. Now I want to know the equation of another line that is perpendicular to it, passing through a particular point. What's the point? -1 and 4. How do we go about this? So the original line is this, suppose this original line. So we know the coordinate of this point. So this -2.3, 1, minus 2. So we have a particular line that is perpendicular to it. And this line is passing through, what's the point? -1, 4. This point here is what? -2, 3. This point here is what? 1, -2. Now the thing is, we want to know the equation of this line. To know the equation of any line, you have to know its gradient. Right? So this particular line, do we know its gradient? Yes, we've gotten it. The gradient of this line is what? It's 5. And if you look at it here, it's very obvious that they are what? Perpendicular to each other. Now our aim is to know the perpendicular distance, meaning we want to know from here to here. We want to know the distance, let's call it d. To know distance between fixed points, we have to know the coordinate. We know the coordinate of this point, but for this point, we don't know the coordinate. Let's call it what? x0, what? y0. So by the time we know this value of x and y, we are done. Or let's just call it x and y. If you know the value of x and y, then we can use the formula for distance between 2 points to get it. Now the question is, how do we get the value of x and y? This is what I'm going to do. For the first line, we know its equation. We have to first get the equation of the second line, this line. And this line is perpendicular to it. So let's get the equation of a line perpendicular to this. Now since this line here is perpendicular to it, so it means the gradient of the second line, let's call it m2, equals to -1 over m1. And m1, this line grades already 5. We've done that already. So that's -1 over 5. So using the formula, m equals to y minus y1 over what? X minus x1. So we can say the gradient of this line is -1 over 5, which equals to y minus, let's just call this x not y not for a reason. So I don't know which thing is y and x equals to this. So, oh wait, still the same thing. Yeah, still the same. So what is our x1? Our x1 is -1. Sorry, y1 is 4 over x minus, what's x1 here? -1. So when we have -1 over 5 equals to y minus 4 over x plus 1. So from here, you can just cross multiply, they will have what? 5y minus 20 equals to minus x minus 1. So you can also write this in this form. I can bring this minus x here, become plus x. So this is what? X plus 5y equals to, this one will come here. I have -1 here already. If this minus 20 cross become plus 20, minus 1 plus 20 gives us 19. So this is the equation of what? Of this line. Then for the equation of the second line. And already from D, we already told to look for the equation of this. We already know the equation of this line. So the first line, the equation of the first line, as it was written earlier, we have y equals to 5x plus 13. So we can also write as what? 5x minus y equals to minus 13. Meaning this one was taken here, become minus 13. This y comes here, become minus y. So it means for the first line, the equation is what? 5x minus y equals to minus 13. So this is the same thing as the equation of the first line, although written in another form. Now here we have two equations, and they cross this line, the second line and the first line, the original line. They cross themselves. They cross here. So whenever two lines crosses each other, at that point they cross each other, they will have the same value of x and value of y. So after getting this, we are not going to solve simultaneously. So which method should we use? Let's try to use elimination. So I can multiply this one by what? 5. So equation 1 becomes 5 times 5. We have 25x minus 5y equals to minus 65. That's still our equation 1 written in another form. Then equation 2, we have x plus 5y equals to 19. That's our equation 2. So if we add this, 25x plus 1x, that's 26x. Minus 5y plus 5y cancels. So minus 65 plus 19 gives minus 46. So to get the value of x, we divide by 26. So x equals to minus 46 over 26. 6 cancels 6. 2 here 1, 2 here 2. So the value of x equals to minus 2, right? It's funny. That's wrong. And from here, what next? They are both even numbers, so 2 is common. So the answer is minus 23 over 13. I wish can get a good number here. So that's value of x. We cannot get y. We can get y from equation 1, original equation 1. We can even use this one straight. If we make y the subject here, we are going to get y to equals to 5x plus 13. So we want to get y. And what is x? Minus 23 over 13 plus 13. So from here, y equals to 15 multiplied by minus 23 gives minus 115 over 13 plus 169. What else is to combine these two together? So from here, if you proceed, we'll get the value of y to be minus 54 over 13. So and what is the value of x? X is already minus 23 over 13. So x is minus 23 over 13. And y is minus 54 over 13. So meaning we already know the coordinate of this point. So we now have 2 points. This point here is minus 1,4. And this point here is what? Minus 23 over 13, minus 54 over 13. No. Now having these 2 points, what next? We can now use, since our aim is to know the length of this, which is the perpendicular distance of this point from that line. So this will be our, you can call n of them x1, y1. So this one can be our x1, y1, our x2, y2. So distance between 2 points equals to x2 minus x1 all squared plus y2 minus y1 all squared. So the best is, it will be easier if you make this answer to be in decimal. This in decimal, this in decimal. Then we'll impute the value here, and we are going to get the value of distance to be equals to approximately 8 units to the nearest whole number. So that's the answer to question I. So and this I is one of the most difficult questions you can ask you under this. As you can see, the steps is a bit long. The first thing you have to do is to get the equation of that line. Whenever you want to know the distance between a point from a line, we have to first get the equation of that line joining the point and of a perpendicular line. Join that point and the line first. Oh, we did here. So after I get the equation of this line, we will now solve simultaneously to get x and y. So that x and y will be the coordinates of this point where the two lines met. Then you now use the formula for distance. Although there is a shortcut for this. Yes, there is a formula we can use directly. And that formula is generated using the steps here. So I'll give you the formula, but before that, let's do J. J is almost the same as I, but a bit simpler. So for J, the equation of a perpendicular bisector to the line. So we already know the line, minus 2, 3. And what do you have here? 1, minus 2. So we understand meaning of what? Bisector. Bisector is what cuts something into two. So this line has a midpoint here. So if you have another that is perpendicular and pass through the center, so this line is what we call the perpendicular bisector. And it, the equation of perpendicular bisector to the line. Now, to know the equation of any line, we have to know its gradient and the coordinates of a point. So this line, what was the gradient of this line? Let's call it M2. This M1, the gradient is what? 5 from beginning. So obviously M2 is what? Minus 1 over 5. So we know its gradient. If we know the gradient of a line, we can always get the equation by using what? M equals to y minus y1 over what? X minus x1. So what is M minus 1 over 5? What was that? X1, y1. So there is no information given about this point. But the thing is, this line and this one, they met here. So meaning they are going to have the same coordinate here. Now, seeing this line bisect this line to 2. Meaning this point is a midpoint between what? This point A and point B. So these are what? Xm, Ym. So what I want to apply here, to know the coordinate of this point is actually what? The coordinate of midpoint of that line. So our x or y1, the coordinate of this point, which appears to be on this line, is set as what? Ym over xm. So our aim now is to get the coordinate of the midpoint, which is very simple. So these are x1, y1, these are x2, y2. The coordinate of the midpoint of the line, which is xm, ym, equals to what? X2 plus x1 over 2, y2 plus y1 over 2. We've done that earlier on where we got minus half and half. I think this is it, yeah, B. But let's do it again. So our xm becomes, what is x2? x2 is 1. What is x1 plus minus 2? What is y2? y2 is minus 2. y1 is 3 over 2. So the coordinate of the midpoint is xm, ym equals to 1 minus 1 minus 1, there were 2. Minus 2 plus 1, that's what? 1 over 2. So we now come back here. These are M2. What's M2 using this formula? That will be minus 1 over 5 equals to y minus, what is y1? Sorry, what is ym? These are ym, half. Over x minus, xm is what? Minus half. So from here, if we continue, we are going to be having minus 1 over 5 equals to y minus half over x plus half. Because minus is plus. So we can cross multiply. 5 times y, we have 5y. Minus 5 times half, that will be 5 over 2. Then x times minus 1 is minus x. Then half times 1 minus 1 is what? Minus half. From here, we can make y the subject. Or no, let's just, since we have fraction here, let's write 2 by 2 straight. So 2 times 5y gives 10y. 2 times, this 2 cancels 2, I have minus 5. 2 times minus x minus 2x. Then minus 1. So we can write this as, let's make this one here. 10y, this minus 2x comes here and becomes plus 2x. 2x plus 10y. Let's bring this one here. Equals to minus 1 plus 5. So 2x plus 10y equals to 4. I think 2 is common. Let's divide 2 by 2. So it means x plus 5y equals to 2. Or we can write as what? X plus 5y minus 2 equals to 0. So we can write the equation of the line this way. Or we can make y the subject. If y is made the subject, y becomes minus 1 over 5x plus 2 over 5. And that's the what? The equation of the perpendicular bisector to this line. And this is the end of the first part. The next is for us to look into application of coordinate geometry. But before we move to the application of this concept, let's try to solve one or two questions. Alright, consider the following question. Find the equation of a line perpendicular to this particular line. So this first line, we have 2x plus 3y equals to 1. We can make y the subject. And after making y the subject, we get minus 2 over 3x plus 1. You make this one the subject. So this particular line, the gradient of this line, let me call it m1, is minus 2 over 3. So, but the line, what's the equation we want to get? Is perpendicular to this line. So when the line is perpendicular to the other, the gradient of the other equals to negative reciprocal of the first. So our m2 becomes, if you negate 2 over 3, that becomes, if you negate minus 2 over 3, it becomes 2 over 3. Then we do reciprocal, it becomes what? 3 over 2. So that's our m2. Then we use the general form, m equals to y minus y1 over x minus x1. So the line whose equation we want to get, the gradient is 3 over 2. Then y minus, what is y1? Y this x1, y1. That is minus 4 divided by x minus 1. So this is 3 over 2 into y plus 4, x minus 1. By the time we cross multiply, we are going to have 3x minus 3 equals to 2y plus 8. So let's bring this one here. So we have 3x minus 2y equals to 8 plus 3. Hence, the equation can be written as 3x minus 2y equals to 11. So I like the answer in this form, so that because the question is in this form. So you can also write the equation of the line here, not necessarily making the y the subject. But if we decide to make y the subject, the value of y here becomes 3 over 2x minus 11 over 2. So we either leave it in this form or this form. But this one is more useful. Why? Because from this form, we can easily say this is the intercept, this is the gradient. For this particular equation, this is the intercept, this is the gradient. So now, let's now move to the second question. Find the equation of a line passing through the origin. In this case, it passes through 1 minus 4. When a line passes through the origin, when I have a Cartesian plane, the origin here means x is 0, y is 0. So meaning we already given the point is passing through to be 0, 0. Passing through the origin and the point of intersection of this line and this line. Here we have two lines. So let's suppose we have this first line and this second line. So these two lines, they intersect here. Any point, if two lines cross each other, that point of intersection, if you trace to the x-axis and y, it means at that point they will have equal value of x and y. So when two lines crosses each other, we solve them simultaneously to get what? The point, the value of x and y. So we can get the coordinate of this point. So when we solve this and this simultaneously, the answer we are going to get here will be what? The coordinate. We can call this one x2, y2, because it's as though we are given x1, y1. So let's do that first before we get the equation of the line. So we have 3x plus y equals to 4. We have 2x minus y equals to 1. We can eliminate by adding because this will cancel out. So 3x plus y is 5x equals to 5. From here, x equals to 1. After getting the value of x, we can get that of y from equation 1. So we can come here and say 3x plus y is 4. So our x is 1. 3 times 1 is 3 plus y is 4. So y is what? 4 minus 3. So y is 1. So it means this point where these two lines cross each other, the coordinate is what? 1, 1. So we are told to find the equation of a line passing through the origin and the point of intersection of these two lines. So meaning the particular line whose equation we want to get is this. So we want to get the equation of this line here. And to get the equation of a line, what do we need? We can use this formula. We can use m equals to y minus y1 over what? X minus x1. Now, in this particular question, we are not given a gradient. So whenever we are not given a gradient, we put the formula of gradient there itself. That's y2 minus y1. Let me clean this. Or don't worry, let me just write below it. So our m itself is y2 minus y1 over what? X2 minus x1 equals to what we have here? Y minus y1 over x minus x1. So this itself is another what? Equation of a line. Whenever gradient is not given, but we have the coordinate of 2 points. And here, yes, we have the 2 points. 0, 0, this is a point, 1, 1, this is another point. So we can call this one x1, y1, x2, y2. Now, let us substitute the value. What is y2? y2 is 1. What is y1? 0. x2, 1 minus 0 equals to y minus, what is y1? 0. X minus x1 is also 0. So 1 minus 1 is 1. 1 minus 0 is 1 over 1 equals to y over x. So by the time we multiply, you are going to get to a y equals to x. So this is the equation of the line. So it means the slope of that line is 1 and the intercept is 0. Meaning it passes through the origin. And that is the answer. Now, for this question, find the gradient of this line. We have y equals to mx minus y. What is gradient? M itself is the gradient. So from here, make m the subject. M equals y plus, y plus 5 over x. So you are going to find all of m. But luckily, we are already given a point to pass through. So this is our x, y. You can call it x1, y1. Doesn't matter. So from here, our gradient m becomes, what is y minus 3 plus 5? What is x? Half. From here, m becomes 2 divided by what? Half. So if we divide 2 by half, we get 4. But this is what? 2 times 2 by 1. So m is what? 4. So you may be thinking that if we divide 2 by half, the answer should be what? 1, right? No, if we divide 2 by half, the answer is 4. What if we divide 100 by half? If we divide 100 by half, the answer is what? Not 50, the answer is 200. So I didn't say divide 100 by 2. If we divide 100 by 2, we get 50. But if we divide 100 by half, we get 200. Now let's talk about the application. One of the applications of coordinate geometry is area of polygon. We can use this topic to get the area of what? Polygon, starting from triangle, quadrilateral, pentagon, upward that way. If we know the coordinates of the vertices, consider this Cartesian plane again. If you have 2 points on this plane, let's suppose I have this point and this point. So if we join these 2 points together, we get a straight line. Then we can know the distance between them, which we've done. But let's suppose we have another point here. If we join these 3 points, we are going to get a triangle. Let's do that. Now, this point will all have their coordinates. So this point, its own coordinate is going to be, let's say x1, y1. For this one, it's going to be, okay, let me start from this one. Let's go this way. So this one is going to be x2, y2, and this one x3, y3. So we know the coordinates of all these points. So this is the first point, point 1, point 2, and point 3. So what's our aim is to get the area of this shape? Triangle. How can we get this? But if you look at this shape very well, look at it, follow this path. This is a trapezium. This is another trapezium. 1, 2, 3, 4. 1, 2, 3, 4. Then we have this trapezium here. Let's shade out all those trapezium. Let the area of the trapezium be, let's call it A1. Then we have another trapezium here. Let the area be A2. So if we add A1 and A2 together, the area of the triangle itself, let's call it A. The triangle itself, let's call it A with blue ink. Then we still have extra trapezium here, this one here, with black dots. This one. All of this. So let's call that black dots, everything together here, A3. It's obvious that if I add A1 and A2, it will give us what? A plus A3. But our aim is to get A. So we can say A equals to A1 plus A2 minus A3. And A1 is the red trapezium, A2 is the green trapezium, A3 is the black trapezium. And we know in general that area of a trapezium is what? Half addition of the parallel side times what? Perpendicular height. So for me, our A becomes, for A1, what are the parallel side? This length. From here to the origin, that's y1. So that's half. Let me write this one by one. A1 is half this one and this one. So from here to here down is y1 plus from here down is what? Y2. Then what's the height here? That difference between x1 x1. That's x2 minus x1. So from there we can get our A1. So for A2, what's A2? That's also half. The parallel side, our A2 is the green, everything here. So that's Y2, Y3. Y2 plus Y3 times from here to here. That's X3 minus X2. Then what's our A3? This one down here. What are the parallel side? That's Y1 and Y3. That's half Y1 plus Y3. Then from here to here is the base or the height. That's X3 minus X1. So we can get the value of A1, value of A2, value of A3. Then we add these two, subtract this from it to get the area of the triangle, and that was all. I prefer not memorizing the formula, so you can always sketch and get this value straight. But if we want to memorize the formula, yes, we can go on with it. So let's try to impute the value of A1 here. This A2 replace with everything here. A3 replace with everything here, and see what we're going to get. So we're going to have this after we substitute all of A1, A2, A3 to that. Now, half is common. Let's bring out all the halves. By factorizing half, we are going to get this. So let's expand this, but we're not expanding the whole bracket. So let's expand only y. Let's expand only y. So from here, we can say the area equals to. So this y1 can multiply this bracket, then y2 also multiply it, then we are going to have. So let's do the same thing for this. Y2 multiply the whole of this, y3 with this, and also the third one to see what we are going to have. So this is what we are going to have at the end. Then from here, if you notice, we have y1 here, another y1 here. So if I factorize y1, we have to add what you have in this bracket with this. So I have x2 minus x1. Minus x1 plus x1 will cancel. So I'll be left with what? x2 minus x3. Let's do same for y2. y2 is common here. So what happened? This x2, we have minus x2 here. So we have what? x3 minus x1. So we are going to have y2 into bracket what? x3 minus x1. Then for y3, we have y3 here. We have y3 here. So upon x3 as minus, x3 as plus. So I'll be having x1 minus x2. y3 equals into what? x1 minus x2. And this becomes the area of the triangle. If you are good at memorizing, you can just put this at the back of your mind. But if you're like me that you don't really like to memorize lots, so when you are doing the coordinates, you sketch the triangle, then we use the step. It's an area of triangle, then we add the two trapezium minus the one below, then we get the answer straight. So whenever you are told to find the area of a triangle and you are given the coordinates of the vertices, the best is to use this. Although it might come to your mind that, oh, if I know the coordinates of this point and this point and this point, we can look for this distance, this distance, this distance, yes. And for a triangle, if the three sides are known, we can just apply Aaron's formula. Or you can apply cosine rule to get one of the angles, then apply half AB sine C. But that will be too long. It will take time because you have to get the distance, and sometimes most of the distance will be in fraction, big numbers. So the best is to use this approach. Now, next shape after triangle, the next polygon is quadrilateral. Let's look into that. So a quadrilateral is a four-sided shape. So here we have four-sided shape. So if you have a quadrilateral, every quadrilateral can be split into two triangles. So let's draw this point to this point to see what you're going to have. So what do you notice? We have two triangles. So what are you going to do? Using this approach, get the area of the triangle above, then get the area of the triangle below, then add, finish. So for a triangle above, since you know this coordinate and this coordinate with this, so you can just straight this one down as our point 1, point 2, point 3 for x1, x2, x3. So these are x1, y1. This x2, y2. This x3, y3. So we can use this formula to get the area of the one above. Why for the one below? This is our x1, but this is now our x2. Our x3 remains. So this point will become our second x2. So we can write as what? x2 bar. And there will be what's here? y2 bar. So we leave at this point first. Then when we are done with this, then our x2 and y2 we have a new value. So we come here, we replace this x2 here and this x2 here with the new value of x2, and replace the value y2 with the new value of y2, and with that we are done with the area of this quadrilateral. What if you have a pentagon and we know the coordinates of the vertices? So quadrilateral has 2 triangles. Pentagon can be made to have what? 3 triangles. So what can we do? We can join this point to this point, then we can join this point to this point, or this point join it here, this same point join it here. We are going to have 3 triangles. So these are point 1, these are point 2, these are point 3. So we are going to get the area of the first triangle using this coordinate under x, same goes for y. Then also for the second triangle, these are point 1, this point 3 will now becomes our point 2, this will be the new point 3. And this one will be that's the power bike. I will get my own soon, but let's leave that apart. So first we get the area of this one on top using those 3 points. Then after we can get the area of this second one. Then we just call it 0.5. So consider 1, 2, 3, then 1, 3, 4, then 1, 5, 4. Our hexagon, same thing. We can always link everything back to triangles. And we can go on and on and on. Then the last thing we're going to talk about before we go into solving question is collinear point. When you hear the word collinear point, it means the points, when we have points that appear on the same straight line. This point, this point, this point, they are collinear because they are on the same horizontal point. Now when you come back here, this point 1 and point 3, they are collinear. But point 2 is not collinear. There's an angle here. But as point 2 approaches this line, this angle will increase till 180. And when this point 2 get to this line, what happens to the area? The area becomes 0 because we are not going to have triangle again, they are having a straight line. So for 3 points to be collinear, the area, if those 3 points are taken to be what? Are going to be a triangle, the area of that triangle is going to be 0. So if they ask you, show that these 3 points are collinear, you just do that. Or the question can be asked in other form. When 3 points are collinear, what happens? The area becomes 0. So there might be a need for you to memorize this formula. But let's find a pattern. So just know we have half. Y1 is here, Y2 is here, Y3 is here. You can see Y1, Y2, Y3. So if there is 1 here, inside brackets we have 2 and 3. If there is 2 here, we don't have any 2 here. We have 3 and 1. If there is 3 here, we don't have 3 here, only 1 and 2. And what's the arrangement? You can just memorize this one. 23, 31, and 12. So 23 means I'm going to have x2 minus x3. Let me write it out. So it has a pattern. So remember 2, 3, 2, 3, 3, 1, 1, 2. So that will be x2 minus x3, x3 minus x1, x1 minus x2. Then outside what? y1, y2, y3. So let's take example on this. So we are told to find the area of a triangle which has vertices with coordinates 1, 2, 4, 1 and 3, 3. So we have to use the formula. Recall the acronym. What's the acronym? 2, 3, 3, 1, 1, 2. So the area of that triangle equals to half into right y1, then that will be x2 minus x3 plus y2, x3 minus x1, then minus y3 into what? x1 minus x2. Sorry, it is plus y3. Now, in order not to make any error, if you observe x1, x2, x3, they are in order, increasing in order. So we check, this is the least value of x. So we have points 1, 2. So this is x1, y1. We have points 4, 1, but 3 comes before 4. So we are going to do point 3, 3. So this is x2, y2. Then we have 4, 1. Let's screen the acronym. x3, y3. What else? Let's impute the values. What is y1? y1 is 2. What is x2? x2 is 3. What is x3? x3 is 4. Plus what is y2? y2 is 3. x3 is 4 minus x1 is 1. Then plus what is y3? y3 is 1. x1 is 1 minus x2 is 3. Then from here, a becomes half of 3 minus 1 minus 4 is minus 1 times 2, that's minus 2. 4 minus 1 is 3, 3 times 3, 9. 1 minus 3 minus 2 times 1 minus 2. So here our area becomes half into minus 2 minus 2 minus 4. 9 minus 4, that is 5. So the area equals to 2.5 square units. As simple as that. Rather than wanting to get the distance here, use cosine to get the angle and apply what? Area of triangle as half AB sine C. That will be too long, as you can see. Although, if you didn't arrange in order of increasing x, 1, 3, 4, if you just use this one as x1, y1, x2, y2, x3, y3, at the end we are going to get minus 2.5. So we can just neglect it. So we can say the area is the absolute value of this. You just follow the point the way it is. So it means when we solve, let's suppose this is the original triangle. So if in order, if you didn't put in order, it's as though we are solving this particular triangle. And this time around, what happens? This one is like a negative of this. We'll move it down. So when we take the absolute value, we get the same what? Answer. These two triangles have the same area. Okay, let's take an example on this. Alright, look at this question. Calculate the area of quadrilateral whose vertices are this, this, and this. A, B, C, D, E. So let's label this as A, B, C, D. So first is to get the area of triangle ABC. ABC. So meaning we are going to use the first 3 points, ABC. So now let's get the area of triangle. So area of trapezium, so area of quadrilateral equals to the area of triangle ABC plus area of triangle ACD or ADC. So for triangle ABC, we record the formula half into bracket y1. What's the acronym? 2, 3, 3, 1, 1, 2. Then y1 into what? x2 minus x3 plus y2 into x3 minus x1 plus y3 into x1 minus x2. So what are the 3 points? We are using ABC first. We have 1, 1, then we have 2, 5, and we have 5, 4. So these are our x1, y1, x2, y2, x3, y3. So let's impute these values inside this. So if you impute the value of y1, x2, x1, and the likes, we're going to get that. So at the end, 2 minus 1, 1, 1 times 1, 1, 5 minus 1, 4 times 5, 20, 1 minus 2 minus 1 times that, that's minus 4. So 20 minus 4 is 16 plus 1, 17. So the answer is half of 17. That's area for triangle square units. Area of triangle ABC. Now what about triangle ADC? We've done ABC. Now ADC. For ADC, we are still going to use the same formula, but we are using point ADC. A, D, then C. So with this is our x1, y1, x2, y2, x3, y3. Then using this, let's impute everything in triangle ADC. So y2 is 0. Since y2 is 0, we don't need to put anything here. What's y3? y3 is 4 here. Then x1 is 1 minus x2 is 4. So this becomes half of 4 minus 1 is 3 times 1, that's 3 plus 0. 1 minus 4 is minus 3, that's minus 12. So from here we're having half of So 3 minus 12 is minus 9. So this, well, I told you we are going to use the absolute value, so you negate the negative value. So that's just half of 9. So the area of the whole triangle, sorry, the whole quadrilateral is half of 17 plus half of 9. So half is common. So if you add 9 plus 17, we are going to get 26. Am I right? Yes. So what is half of 26? 13. So the area of the quadrilateral is 13 square units. As simple as that. So this will be the end of the application to this topic. See you in my next class.